This video is entitled Logical Data Models and is the third video in the Entity Relationship Diagramming group. This video goes along with our Systems Analysis and Design course, Topic 6, and I'm Jim Renaud, PhD from Shawnee State University, and I'll be taking you through this video lecture. So in the last video, I introduced basic entity relationship diagramming using and drawing something called a subject area model, where we just basically have entities and relationships. Now, to go into a logical model where we start adding details, there are really four things we need to add and refine in our subject area model. The first is to add our attributes. In the entity, down in the bottom section of it, start adding the attributes that we're going to need to track about each of the entities. The second thing we need to do after we identify those attributes is to identify and try to figure out what a primary key for each of those entities, each of those entity rows would be. Now, a primary key is a unique identifier that defines each row or each instance of the entity. So, for instance, if the entity was student, then a good primary key might be student ID number, because the ID number uniquely identifies each student. If the entity were items that we sell in our store, then a good unique identifier for each item might be the barcode, the UPC code. Maybe we have a table of vehicles with information about their various vehicles. Well, the vehicle identification number or serial number might be a good identifier. So each table, each entity needs to have an attribute or a group of attributes concatenated together, jammed together, that are unique and uniquely identify each individual row. The third thing we need to do as we move from subject area model to logical data model is to eliminate the many-to-many relationships, because we're not able to actually create a database with many-to-many relationships using the relational model. And then what we need to do after we put these new tables in the middle is that we need to define foreign keys, and a foreign key is used to implement the one-to-many or one-to-one relationship. I'd like to talk a little bit more about foreign keys, though. A foreign key is where we take the primary key of the one table and place it as an attribute on the many table. So the primary key of the one table is an attribute on the many table and contain the same information. Now, they might have different names on the two different tables, but they still will be what creates the relationship. The foreign key on the many table points us back to the primary key of the one table to get the information that we need to bring those two tables together. So you really need to commit this to memory, that you take the primary key of the one table and add it to the many table as a foreign key. Take the primary key of the one table and add it to the many table as a foreign key. Now, it can be part of the primary key of the many table as part of a concatenated key, and we'll see some examples of that as we move through. But you really need to commit, we take the primary key of the one table and add it as an attribute of the many table as the definition of a foreign key, and to keep that in your head at all times as we're doing this database modeling. So here's the example that we had from video 6b, where we have a region that has many stores, and a store belongs to one and only one region. An item is stocked in many stores, and a store stocks many items. So let's take this subject area model and move into the logical data model. This slide is quite complex, but I'm going to walk through each and every piece of it, so don't freak out yet. Let's look that we have our three entities, region, store, and item, And I started just listing attributes for each one of them. For instance, in the region table, in the region entity, I said, well, each region has a region code, there's a region name, there's a manager name, and there's probably a whole lot more attributes that we might have on the region, but those were the three that I identified at the very beginning. Let's look at a store. Now, what attributes follow a store? Each store is its own individual thing. So, what are the attributes that go with the store? The store number. Yeah. The address of the store, the city, the state, the zip, the country of the store, because we're an international operation, our phone number of the store, our manager name of the store, and what region the store belongs to. Um, then we start adding attributes to the item table. The item table may have the UPC code, which is the Universal Product Code, or that barcode that you'll see on items in the store. An item will have a description that you'll see on the shelf tag or in the online catalog. An item will have a price. Um, and an item may have a lot of other attributes, color and what category it belongs to or whatever. But you can see that we've started creating the attributes. Now, the next step would be, now that we've identified attributes, what would the good primary keys for these tables be, these entities be? Well, the code number that we assign to each region is small, it's unique. Every region has their own code, so region code would make a good primary key, and that's why I underlined it here in blue. For stores, same thing. Store number. We're only going to have one store with that store number. It's a unique piece of data, so let's make that our primary key. Could we have used address and city, state, and zip and country and jammed them all together as a primary key? Yeah, but that gets to be complicated. That's rather complex, where it's just simpler to say store number. So I'm going to make the store number the primary key here. And for my item, um, the item has kind of a very natural primary key. It has a barcode on the bottom of each item, and that barcode is unique to the item. The manufacturer puts it there. So that would be a good primary key. Only one item has that barcode, so then its description and price follow. So we've now identified our primary keys, and I've again marked them in blue. Now, let's identify some relationships. Well, the relationships were on the previous diagram, and I'm going to show that the region code, the relationship between store and region would be a region has one or more stores and a store belongs to one and only one region. To implement that one-to-many relationship, we take the primary key of the one table and put it as the foreign key on the many table. So we take the primary key of the one table as a foreign key on the many table. So each store would have a region code, and with that region code, we could come over to the region entity, look up the region code, find the name and the manager of the region so that the store can see who the regional manager was, or you can see the relationships between them. Now we have the relationship between store and item, though, that's still problematic, and that's why I drew it in yellow, because a store stocks many items and an item is stocked by many stores. That's a many-to-many relationship, and we need to eliminate that many-to-many relationship now as we're moving into the logical data model. So, to implement that many-to-many relationship, what I did here was I created a table in the middle, an entity in the middle between store and item, because a store has an inventory of items. And an item is in many stores' inventories. Yeah, that does make sense that a store would have an inventory of items and an item would be in many stores' inventories. So, if I put this entity in the middle, and I could have called it lots of different things. I didn't have to call it a inventory. I could have called it the stock table. I could have called it the on-hand table. I could have called it lots of things. But you can see that a store has many inventory items, but an inventory belongs to one store. An item is on many inventories, but an inventory belongs to only one item. So you can think of each of these inventory records as like a 3x5 card. Let's go back to an old paper system. The store has a index card, a box of cards, and each item would be on a card, and the quantity on hand would be on that card. Each store would have its own box of cards, and you could see that an item is on many cards, one in each store. A store has many cards because it has many items. So that's what we're doing here in the middle. Now, to create the relationships between the store and the inventory and the item in the inventory, I've put the primary key of the store number as a foreign key on the inventory, and I've marked it with a little FK just because that's when I'm drawing a hand-drawn diagram, I'll just mark with an FK and I'll underline the primary key. And then I'll take the primary key of the item and make it a foreign key on the inventory, the UPC code you can see there. And then I said, what's uniquely identifying each of these cards? Well, if we take the store number and the product number, the UPC code number, that uniquely identifies that 3x5 card in each store. The store number with the card number, that would be unique for each store. So instead of creating a non-natural, instead of creating a surrogate key, a made-up key, or some other kind of foreign key, I've said, well, let's put these two attributes together and concatenate them into a primary key. So the primary key of the inventory entity is the store number UPC code concatenated together. Now, there are foreign keys also, which can be a little confusing, but if you stop and really think about what's going on here, it makes a whole lot of sense. And here I bring all of it together, and you can see the results here of a region has many stores, but a store belongs to one region. A store stocks many inventory items, and an inventory belongs to one store. An item is on many inventories, but an inventory is for one item. So the inventory you can think of as the intersection between store and item that contains the quantity of each item at each store. Wouldn't that be the unique value for the store item intersection? The quantity at this store versus the quantity at that store versus the quantity at that store. And in the professional diagramming software, what we do is we put the primary key up in the top box and put the attributes in the lower box. And then I put a little PK beside the primary key attributes and a little FK beside the foreign key attributes. And you can see over on inventory that foreign key 1 relates back to store number and foreign key 2 relates back to the item table. So we've now implemented all of our relationships. We have all just one-to-many or one-to-one relationships, and we've got our foreign keys and primary keys and most of the attributes, and we've got a good logical data model at this point. Let's look at a second example. Let's go back to the 6B video with the degrees and courses and students. So a student has one major and a major has many students. A degree requires many courses, but a course may be on 0 or more degrees as a requirement. So I did exactly what I did in the first example. I came here and I wrote down each of the entities. I then started putting attributes on the entities, like a student would have a student ID and a last name and a first name and a middle name and a birthday and maybe a social security number, and a degree would have the degree code and the degree name and the department that the degree belongs to, and a course would have a course code, course name, description, hours. I then put the relationship here and said, well, I need the degree code to be a foreign key on the student to implement this one-to-many relationship, and you can see there it is as a foreign key. The many-to-many relationship between degree and course doesn't work, so we now need to fix that. So I put a table in the middle called the degree requirements table because a degree has many degree requirements, and a degree requirement belongs to its parent degree, and a course is required on many degrees. It's part of many degree requirements, but the degree requirement has only one course on it. And the student relationship there of a student has one major, and a major belongs to one student. Notice that the foreign key on the student table is called major degree code, where over on the degree table it's just called the degree code. They don't have to have the same name, but by marking it as a foreign key, you can, using a similar name, it makes it a lot easier. So I've created this table in the middle. Now, I've got question marks for the attributes on the degree requirement because is it a required course? Is it an elective course? Yeah. So there, I don't quite have all the attributes yet, but I can start figuring them out. This will work for a very simple school. Will this work for our university? No, because a degree has groups of courses, and it may say you've got to take 3 of 5 of these, or you've got to have all of these, or you've got to have 6 hours of electives, and the electives can be these wild card groups of courses, anything that begins with these 4 letters or anything in this number. Or so is this model going to work for a university like Shawnee for our university? No. Is this model going to track what courses a student has taken and their grades? Not anywhere near. So, would this continue to take refining? Yes. Is this a place that you could start sitting down with a client and say, this is kind of the beginning of what I'm seeing, but I think I've got a problem, and the client will help you through this problem? You need to use your interviews, use your JAD, use your questionnaires, use your job shadowing, and use all of that to continue to refine this and figure out exactly how the relationship between course and degree works. We eliminated that many-to-many relationship, but have we created more problems for ourselves? If we were modeling a very complex school, yes. For the simple problem you were given, this is sufficient. This concludes video 6C on the logical data model, entity relationship diagramming. This video is copyright 2020 by James Imrano, PhD. All rights are reserved, and I would like to say thanks for watching, and I hope to see you again in a future video.